Any data has to be positioned in relation to the Earth's surface, and while the Earth sadly is not flat, we need geographic coordinates or their projections. While GIS natively manages data in the whole range of frameworks and allows transformation from one to another, transferring it to other software for scientific modeling, animation, or geostatistics may introduce spatial distortions as they display data in the Cartesian grid. In this episode, we'll try to avoid such pitfalls, which could obviously result in financial and environmental losses depending on the type of projects we are working on. We need different coordinate systems because of the curvature of the Earth. There are two primary types. Geographic coordinate systems account for the Earth's spherical shape. Projected coordinate systems transform the curved surface to a flat plane and do introduce significant distortions, although simplification is needed to approximate the Cartesian system. The distortions to distances depend on the type of projection used and are either introduced in polar regions, mid-latitude, or equatorial. Projected coordinate systems flatten the surface of the Earth into a two-dimensional plane and are expressed in linear units, typically in meters. In contrast, geographic coordinate systems like QGIS take into account the Earth's curvature and generally define positions using latitude and longitude values expressed in degrees. Web Mercator is a popular projection used in online mapping such as Bing or Google. Name QGIS used together with the Web Mercator systems may cause confusion. In this projected system, World Geographic System is used as a datum for the projection. In other words, coordinates are projected onto the Web Mercator grid, transforming the latitude and longitude in degrees into planar XY coordinates expressed in meters on a flat map. If data in a projected system is transferred into other software which uses the Cartesian grid like Paraview or QGIS, the coordinates will be treated as distances in meters and will be displayed in a different location. Universal Transverse Mercator, UTM, is also a projected system, but it divides each hemisphere into 60 zones, with coordinates corresponding much better with the Cartesian grid. We will use this system to prepare data for transferring into Paraview in text format. Before export, I will need to update the XY attributes by adding new XY fields to layer. Paraview will read this data to be positioned in the Cartesian grid. I will display both data in UTM and the Web Mercator to demonstrate the distortion introduced by the Web Mercator. Next, I will use bounding ruler filter to measure the extent along the x-axis of datasets in both projections. As we can see, the extent of the dataset located at a latitude of about 50 degrees in UTM is about 1,600 meters, while that in the pseudo-Mercator is increased to 2,810 meters. A similar result of about 1,600 meters to that from UTM we get when measuring the extent of the dataset with QGIS using QGIS, which is a geographic coordinate system and is more reliable than measurements on any projections. Although QGIS 84 is available in Blender, it is generally not recommended to use due to frequent errors, while the Web Mercator also included obviously results in geometric distortions. Similarly, QGIS, which is Stanford geostatistical modeling software, requires point data in the Cartesian coordinate system. Data coordinates have to be approximated by the most local projection, particularly with geographically extensive projects. As we can see, data can be easily transferred to 3D modeling tools if we use the projected systems. Spatial distortions may be negligible if validate them using GIS and if necessary introduce corrections. Thank you for your time. Hopefully you haven't abandoned using open tools. Leave a comment about it below and share your experiences.